Arduino Circuitry by Gruboksh. Lesson 1 consists of LEDs, 270 ohm resistors, and a switch. As you can see that the current is splitting equally amongst the two LEDs, making it a parallel circuit. In this circuit, the electrons flow from the ground pin of the Arduino through the switch and resistors of the LED and back through the 7 and 13 digital pins. The current will always flow through the ground pin of the Arduino because it is the cathode, aka the negative terminal. Lesson 3 consists of an RGB LED, 3 270 ohm resistors, and a switch, and this is a series circuit. The ground pin of the Arduino connects to the switch, which is connected to the cathode of the RGB LED. The 3 anode pins of the RGB LED are connected to the digital pins of the Arduino, which are pins 11, 12, and 13. This is a series parallel circuit which consists of 8 LEDs, 9 resistors, an 8-bit shift register IC, and a switch. As you can see, the current flows through the cathode of the LEDs as well as through the pins 8 and 13 of the 8-bit shift register IC. Pins 1 to 7 and 15 of the IC are connected to the 8 LEDs through 270 ohm resistors. As you can see, this circuit is exactly the same as the previous one. The only difference is that we can control the 8 LEDs by using a serial monitor. The X key on the keyboard shuts all the 8 LEDs off, while pressing keys 0 to 7 turns on the LEDs. This circuit includes 3 LEDs, 3 270 ohm resistors, and 2 push buttons. The 2 push buttons are connected to pins 8 and 9, which are the digital pins, as well as the LEDs are connected to the resistors, which are then connected to digital pin 5. As you can see, one push button turns on the LED while the other one turns it off. This series circuit contains only a few components such as 3 270 ohm resistors, 1 RGB LED, and 3 push buttons. Digital pins 9, 10, and 11 are connected to the anodes of the RGB LED, while digital pins 5, 6, and 7 are connected to 3 push buttons. These 3 push buttons are used to control the 3 primary colors of the RGB LED, which are red, green, and blue. By pressing the 3 push buttons, we can mix the colors of the RGB LED. This circuit is the same as circuit number 5. The only difference is that a 10k ohm potentiometer is added. When we turn the potentiometer, the LEDs start to light up in a sequence. I've also added a piezo buzzer in my circuit. As you can see, this circuit is also the same as circuit number 5, but this time we just added a photoresistor, also known as an LDR, which stands for light dependent resistor. When there is a lot of light, the LEDs light up in a sequence, and vice versa. This circuit consists of a 220 ohm resistor, 10k ohm potentiometer, and an LCD, also known as a liquid crystal display. When turning the potentiometer, the contrast of the display can be adjusted. Above and beyond. This circuit contains 7 LEDs, 8 270 ohm resistors, and a push button. This circuit also uses 2 to 9 digital pins of the Arduino. At a push of a button, this circuit generates random LEDs to light up as if you were to roll a dice. This Morse code circuit only contains an LED and a 270 ohm resistor. As you can see, the anode of the LED is connected to the 12th digital pin of the Arduino, and the cathode of the LED is connected to the ground through the 270 ohm resistor. When we write a word on the serial monitor, the LED will light up in 2 signal durations, which are dashes and dots. We can then determine the word according to the Morse code chart.